Now on this page, we'll discuss the properties of R in more detail, the correlation coefficient. Let's see. Remember throughout our discussion that R is a number that measures the strength of a linear relationship. Its sign also gives us information about the direction of the linear relationship. So first property is the units of measurement do not affect R. The correlation does not change when the units of measurement of either one of the variables changes. In other words, if we change the units of measurement of the explanatory variable and or the response variable, it has no effect on the correlation R. So something like if you were measuring the height of a person in feet and you calculated R somehow, I guess that's the X value, and then something else is being measured for the Y value. And then you change it from measuring in feet to inches, for example. So all the data values are going to change in X. So all your ordered pairs are going to change, but it should still be that R is the same. It's a complicated formula, but it takes into account, it doesn't really matter what units you're using for X or Y. Yeah, so in this example, we'll change feet to meters and R stays the same. So to illustrate, compare the two versions of the scatter plot of the relationship between the age of a driver and the maximum distance for reading a highway sign. Because here in the US, we might say feet, but in another country, they might say meters, right? Most other countries would say meters. Let's go down and look at these graphs. So the top one has us measuring in feet, and the bottom one has us measuring in meters, but still the correlation looks pretty much the same. It's just that the vertical axis has changed from when it's on the top one, feet, you're measuring between about maybe 250 as the lowest point to the highest is 600. That's kind of a typical distance, I guess, you're looking at road signs from. But with meters, it's somewhere between 80 and 180, maybe meters. So even though our x-axis has changed, our points pretty much look the same on those axes. And that's why the R value won't really change either. It still would measure how close these are to a line. Like this and this, they're pretty much the same distance from a line no matter what, right? They look like the same points, you just change the axis. So yeah, the top scatter plot displays the original data where the maximum distances are measured in feet. The bottom scatter plot displays the same relationship, but with maximum distances changed to meters. Notice that the Y values have changed, but the correlations are the same. This example illustrates that a change in units does not change R. This is true even if we change the units on both variables. This makes sense because a change in units does not change the pattern or the spread in the data. The direction, form, and strength of the relationship remains the same. Since R measures direction and strength of a linear relationship, the value of R remains the same.